What is a computer program? A computer program, simply put, is a set of instructions that we as humans write to a machine. That's usually the case. The computer program follows a flow. We call it a code flow. Code is what we call the actual statements that we write in any computer language, by the way. So the code flow is the order and the routing of the order in which the statements are being carried out and performed when our code is actually executed. Here you can see a typical computer program flowchart. It always has a starting point, an ending point, and in between it follows a sequence of tasks constructed one way or the other. Another important aspect is to consider the computer language that we choose to use in order to program the code. So there are many computer programs. We will be learning Excel VBA in our course, and each computer program has its own syntax. Syntax is just like any other language that you speak, such as English, Spanish, or whatever. Syntax is the rules of how to put the language in proper order so that the computer actually understands what we are instructing it to do. But usually computer code syntax is not that tolerable as the languages that we speak. So if I speak English and I'm not following the exact rules of the English language, you probably understand what I mean to say. Computers are not that flexible. You need to be very accurate and follow the exact rules of the computer language on which you are coding. Here, for example, you see a typical example of an if-else block. That's a typical structure that you can find in almost any computer language. However, it is written differently in one language and the other. This is an example by which I'm asking whether the age, my age variable, is greater than 30. That's the condition that I'm testing. If it is true, then I'm executing a block of code. In this case, it is assigning the label senior to another variable called my class. However, if my condition is false, I will be executing the else block, which is assigning the junior label into the my class variable in this case. This is, by the way, the syntax of VBA, or Visual Basic. This is, however, the syntax of another language, JavaScript, for example, that is performing exactly the same thing. It is asking exactly the same condition. If it's true, it's assigning senior to my class. Otherwise, it will assign junior to my class. You can see, for instance, that the then and end if are gone. The block of code are designated by these curly brackets that opens and close every block. And you can see that there is a semicolon ending each and every command or statement. Here is yet another way, another syntax of writing that exact same instruction set in another language. So as you can see, the syntax matters. However, you can achieve almost any goal in different languages. You just need to learn the syntax of that language. That said, keep in mind that there are different computing paradigms. So you might encounter, for instance, object-oriented programming paradigm, which is different than the top-bottom flow or structured paradigm. And there are other less popular paradigms as well. So you also need to think the way according to the paradigm that you are using. However, syntax is always important. Now, we distinguish between design time and run time. Design time is when we actually design our code and write the code itself. Runtime is when our code is being actually executed by the machine. There are actually two ways of processing our code. Some languages are interpreter-based and some are compiler-based code. In languages that use interpreter, our code that we write in design time is being executed as it is during runtime, one line after the other, according to the flow of our code. Now, the language that we use is exactly the language that the interpreter during runtime is realizing and translating into executable statements to the machine and executing it actually. So the upside of interpreter languages is that it takes a little bit less memory. We can debug it more easily because it just runs one statement after the other as we've written it, and it stops when it hits an error, and the output is achieved right away. The other way of executing code is by using a compiler. A compilation is a process by which one language code is being provided to the compiler, and an output, which is an executable code, is outputted out of that compiler. So you can think of a compiler as just a translator between two languages. The output language is very well organized language that the machine, computers usually, can process and run in a very efficient way. So the compilation process may take some time. The whole code is being processed and organized and put together in such a way that during runtime it will perform very, very fast. However, it requires a little bit more memory to store that interim machine code, and so that's one of the main downsides of compiler languages. When you typically receive a program to run on your computer and it is already in executable form, usually it has a .exe extension. That's a machine code that was actually produced by a compiler. Typical compiled languages could be C or C++ or Java. Typical interpreter languages are Python or Ruby. VBA is kind of a mix, so it kind of combines and does some hybrid. It has a compiler, but it also compiles and executes the code as we've written it. Kind of a weird animal. We have three main platforms typically: the Windows operating system based platform, the Macintosh OS X by Apple platform, and the Linux platform. And they are not the same. So not every code that is produced to run in one platform will actually run in another platform. Now, some languages produce code that are cross-platform, that can be run on any platform. Java is a good example. Python is another good example. They have interpreters for each and every platform typically. So just so you know, when you write code, you need to target to a platform or design that it will be actually supported by multiple platforms. When we write our code in any language, we can use any flat editor to put together the code. So Notepad, this is a simple text editor that comes together with Windows. Notepad could serve to write our code that we provide to the compiler or to the interpreter. However, since computer code could be complex and we have a lot of objects that we are managing, it is usually a good idea to use an IDE, an integrated development environment, that is geared towards a specific language usually. However, there are IDEs that support multiple languages such as Notepad++. You can tell it which language you're using. It will support you accordingly. And a good IDE helps you in organizing your code, in marking certain elements of the code by colors, so it's easier for you to understand and immediately see what are the objects, what are the variables, what are the statements, etc. It usually has an area on the left where you can organize your objects in a tree-like structure. So you can organize the whole project, the modules and the functions and the subroutines themselves. And it may also provide you with access to properties, events of your objects. So a good IDE is a good trend of us computer programmers. So that was it about understanding of what is a computer program. We'll meet in our next session.